So really pressed for time, but I just got to know, does everybody already have VDI? How many people do not have VDI already deployed? So 1, 2, 3, okay. Really? Okay, cool. And how many of the ones that do have VDI, are you all Horizon View, Citrix? Horizon? Citrix 2? Zen app or Zen desktop, like actual VDI? Okay, cool. Zen desktop's like a licensing thing too. Okay, cool. So, so what I'm going to talk about will apply to everybody then equally, right? I'm going to talk about NSX. I'm going to talk about how it works with Horizon, but everything that I say about Horizon applies equally to Zen as well, to Zen desktop, assuming you're running on vSphere. And we actually do support other hypervisors, but what I'm going to be talking about as far as features and functionality is going to be very specific to that. So my name is Bryan Salek. I've been at VMware forever, almost 9 years now. Spent a really, really long time, just shy of 6 years as an EUC specialist, and I'm now focused on network and security. Our primary product is NSX. So that's what we're going to talk about. We're going to talk about how this comes together with your existing VDI deployments to make them better. Not just more secure, although I'm going to focus primarily on security, but we're going to talk about really how it can enhance the functionality of the experience that you're delivering via VDI as well. So for those of you who do not have VDI, this is pretty much the model you're looking at right now. As far as security model for your desktops, two real big concerns. Data at rest, right? How much data is out there that you care about on laptops that can get lost in airport security or whatever the case may be. And then, your primary threat pattern that you're looking for is north-south, right? It's the traffic that's going in and out of your data center or the traffic that your laptops that are out in the field are potentially exposed to, right? The hostile attackers or whatever the case may be, whether your concern is, security of the enterprise or security of the data in the enterprise. This still pretty much stays the same. When I was EUC for almost 6 years, I was selling federal, right? So my customers were federal, both DoD and civilian. And I can tell you that I can't think of one where the primary driver for VDI was not security, right? That was, right after the VA lost however many million Social Security numbers on laptops, and just there was always one. There were some that weren't publicly reported, right? But there was, security was always a huge concern, and that was the reason that they all moved to VDI, trying to get that data out of traveling around the world and potentially getting lost or stolen or anything like that. So we addressed a whole bunch of things by doing VDI, right? We really made things better from a security posture. We eliminated a lot of threats by bringing everything inside the data center. The problem is that we didn't cover everything. And in fact, in some cases, we made things worse because we took our absolute worst users, our least educated, least technical, least concerned about security, and we put them inside our perimeter firewalls, right? So now, we've been building our data center security around, I think it's my next slide. Well, so let me finish. All of these threats now from outside are available to your users on their virtual desktops inside your firewall. So whether they're going to websites they shouldn't be or they're opening up attachments from in email from people they shouldn't be, they've got full access to these threats. And worse is, for the couple of you who have VDI, are you filtering any traffic in and out of those virtual desktops? What do you have? What are you using? I mean, you got perimeter. I know you have perimeter, but once a virus is on one of your machines, how do you prevent it from spreading? So you're using everything IPS IDS? Okay, cool. That's neat. They must be big desktops. But the risk is that unless you're sending everything out to a firewall, to your perimeter, to the backside of your perimeter, between all of your different VLANs, unless you're segmenting your traffic that way, once a threat is inside your data center, it's free to move pretty much anywhere, right? I mean, that's how Sony happened. That's how JP Morgan Chase happened. That's how Target happened. That's how OPM happened. All these attacks that spent 18 months, the attackers were in there for 18 months, completely undetected. Why? Because instead of it being one machine that's going out spidering the network, which is pretty easy for your IDS to find, right? I mean, that's a lot of traffic. It's easy to find. It's now 10,000 desktops. They can send one packet out every 30 minutes, stay completely below the radar of your security, your IDSs and IPSs, and still map out that network. When they have 18 months to do it, that's a lot of time to figure out what's on your network and what they care about, what they want to steal or what they want to destroy in Sony's case, right? So this is really what we're dealing with now. We've taken this model. This is the way we've built our data centers. Some of us call it the M&M model, right? Hard candy shell. Once you get inside, there's nothing. You can move anywhere you want. Some of us actually have ACLs in place and redirect any routing between VLANs out to a physical firewall, right? If you've got enough money, you can do that because you've got to buy a lot of throughput for those big physical firewalls to be able to handle all your east-west traffic. Gartner says east-west is now 80% of the traffic in your data center. East-west being between two systems inside. Only 20% is actually inbound and outbound to the wide west, right? Most of it stays inside your data center. So what everybody really wants, or at least what your CIOs want, is this. They want a firewall everywhere. Every single app, every single system, they want to put a firewall around it to segment the traffic as much as possible, right? They can ensure that only the right people are getting access to the data and services that are offered by that app, or more importantly, if there happens to be a problem inside this environment somewhere, it can't spread, right? The hot word of the day is ransomware, right? That's the new word. What is ransomware? It's a 0 day that somebody figured out, hey, we can monetize. You know, it's not just about trying to make somebody buy our $60 anti-malware package. It's we can ask for $100,000, and they might give it to us if they want that data back bad enough, right? Yeah, it does some encryption, it does some other fancy things, but at the end of the day, it's a virus that was on your system before your antivirus knew how to detect it. And it changes itself often enough that even when they do update their signatures to detect it, it's already changed and it's hidden, right? So this model allows you to segment it. So even if the problem gets there, you can detect it, but it's isolated. It can't spread. There's obviously the risk to that one system, but beyond that, it's no big deal. So this is where we're trying to go. We can't for two reasons. Either I can't afford the firewall throughput, because it costs a lot, and that's the way most of them license, is by the amount of traffic they need to handle, or I just can't possibly manage that number of rules, right? Every single time I make a change or add a new system, I've got to go update physical firewall rules to be able to accommodate that. We're going to talk how NSX really changes that model and allows us to make this very, very simple to manage. So without NSX, there's a whole bunch of things that you can use to describe your VDI environment, right? It can be more difficult to provision new or to scale out because you've got to worry about provisioning new networks. It certainly can be more complicated when you need to troubleshoot. Vulnerabilities I already kind of beat to death. When you implement VDI, or when you implement NSX with VDI, what you get is a much simpler organization of your virtual desktop environment. Because my networks are now software, and we'll talk a little bit about what that means, but the networks are now part of the VM. They're no longer this thing that I've got to plug wires in and configure it a special way. The network and security policy is now attached to your virtual machines, whether those are servers or they're individual virtual desktops. They now move with the machines. So I don't have to make changes all the time. I can scale out my environment, or I can add new systems, and I can have everything automatically provisioned. And we'll talk a little bit about extensibility too, because this is a key point. For those of you who are familiar with Horizon, you probably are familiar with our antivirus offload. What NSX brings is a whole lot more beyond just antivirus from an offload perspective in terms of improving security and and really enhancing your security vendors' tools. So what is network virtualization? In its most simplest term, today you've got a fabric inside of your environment. Doesn't matter what it is. I don't care who your hardware vendor is. Hopefully it's 10 gig, but it really doesn't matter. You put a bunch of hosts around it, you install our hypervisor on it, and now you've got a vSwitch. You've got virtual networking, okay? Basic virtual networking. What we're talking about doing now with NSX is actually going from creating virtual NICs and virtual switches and simplifying the communication path between your virtual machines and this physical fabric, and we're actually building a network hypervisor. We're completely abstracting everything that runs on top of here from anything underneath. I don't care if this is multi-vendor, I don't care which vendor it is, as long as it's IP, AppleTalk won't work, but as long as it's IP, I can now virtualize all of the networking that you need inside of your virtual environment. And those networks now are part of your virtual machine, and they actually act just like virtual machines. I can snapshot them, I can clone them, I can delete them, I can revert to snapshots, all the same things that we've come to love about virtual machines, all the operational efficiencies, I get them all from NSX now too, for my networks. What we're really doing is adding all the layers of your physical network. We're adding that functionality inside the hypervisor. Layer 2, Layer 3, Layer 4. We do firewalling all the way up to Layer 4. Integration or interaction between your physical and virtualized worlds inside of your data center. And even Layer 7 services like DHCP relay, load balancing. All of those capabilities are now built into this platform. They're part of vSphere. Most of it's there already today, and a license unlocks it. There's a couple of VIBs that we install when you actually go through the process, but most of the intelligence is already there. It's just unlocked via NSX licenses. Any questions so far? Shoot.
So with NSX, I've heard that you actually have to have the VDS implemented in order to take advantage of NSX.
100% correct. NSX works on top of the virtual distributed switch.
Which means you have to have an Enterprise Plus license in order to use that.
Absolutely incorrect. NSX now includes virtual distributed switch. You have to be vSphere 5.5 Update 3 or later, but if you're anything newer than 5.5 Update 3, when you install NSX, it unlocks the functionality of the virtual distributed switch. So you don't get the other Enterprise Plus stuff, but you do get VDS so that you can deploy NSX. Okay? So there's three broad categories of what NSX brings to a VDI environment. Network virtualization, which I touched on. I've touched on security. We're going to dive a little bit deeper into what this really brings. And then edge services. This is some of the other things that we talked about. We've got VPNing capabilities and load balancing capabilities. I'm really not going to touch too much on these. I want to focus mostly on security because I believe that's the biggest bang for the buck in terms of really enhancing your VDI environments. So, fairly typical data center. You've got trust zones that serve different purposes inside of your environment. As you build out a VDI environment, you put the different pieces of the infrastructure and the virtual desktops in different areas. Right? Today you create pools in Horizon and you associate them with certain VLANs that are part of these trust zones so that you can segregate your finance users from your ops users from pick your different types of users, your call center users, your remote users, whatever the case may be. You spread them out around this environment. And that's all okay, except that you've got to make changes to all of the physical infrastructure that exists underneath here. So I start building out my virtual desktops inside the data center, but I've got switches and routers and firewalls down here that all have to be configured to accommodate the changes, right? These new desktops. And certainly as I want to grow my environment, I've got to update ACLs and I've got to update firewall rules and I've got to make changes to my trunks to put certain VLANs on different parts of the network, on different physical ports. All of that ends up being fairly complicated, but typically not an everyday task. Now it gets a little bit more complicated as I start to figure out all the different flows that are necessary. I've got different types of users that need different types of accesses. They have to get from different places, from different virtual desktops, to different places inside the environment. And it starts to get really ugly, right? My developers need different things. My remote access people get different things. It starts to get very difficult to maintain this. And let's not even talk about what it's like to troubleshoot when somebody calls in and says, hey, I got a problem, right? It ends up being kind of a mess, right? And virtual desktops were great, right? We moved everything inside the data center because we wanted to bring it closer to our administrators. So it was easier for them to take care of. In reality, sometimes troubleshooting VDI takes longer than it did to troubleshoot a physical box, where I could walk out to somebody's desk and swap out a hard drive and start over, right? And I don't mean to sound doom and gloom, but it can be complicated. Once I've got all of this ugliness inside of software, it's pretty simple for me to do the same thing. I can automate it all if I really wanted to. I can automate it via scripts, via API calls. I can automate it via whatever my cloud management platform is, whether that's vCenter or something more elaborate like vRealize Automation or any of the competitive solutions out there, because it's all just exposed via a RESTful API. So that's all well and good from a network virtualization and helping to simplify the architecture. But what I really want to focus in on is security. Anybody familiar with this term, the Goldilocks zone? It's a NASA thing, right? Too hot, too cold. Earth is in this perfect place that it had to be for it to support us. NSX is the baby bear, right? We are inserting all of these services right inside the hypervisor. Security puts this in a perfect perspective for us. In today's world, I can put security in one of two places. If I put it inside my guest OS, like your semantic deployment, I get the ultimate in context. I know which user or which process tried to take some action that my semantic software just determined was hostile. And I can make a decision based on not just whether or not it's hostile, or whether or not it looks hostile, but based on whether or not this user should have been making that call, or this process should have been making that call. I get great context about what's going on. What I don't get is isolation. That's what a 0-day is, or ransomware, or call it whatever you want, right? It's a problem that exists before we know how to detect it. That's why all the antivirus vendors push out updates at least once a week, if not more often, because they're trying to stay on top of this ever-growing set of threats out there. The opposite end of the spectrum is down here, right? This is your physical firewall, your physical IDS, IPS, all of the other solutions. Down here, this is the maximum isolation. I can just cut off my data center from the outside world if I really feel like I'm under attack and I don't know what to do about it. Problem is I have no context. I mean, I might be able to look inside the packet if I got a next-gen firewall. I might be able to see who the user was if it's provided inside of that packet, right? But in reality, I've got very low context. When we now take, and of course I have no enforcement, but now if we put security inside this layer in the middle, do we get maximum context? vCenter knows everything that's going on inside your VMs, right? It can see everything. It can see your memory pages. It can see your processes that are running. It can see your disk. It knows everything. It also controls the virtual ports. It can immediately isolate anything inside of that environment. I now get the maximum of both worlds. And we're going to talk a little bit about how this doesn't just benefit NSX, but it benefits Symantec, McAfee, Trend, Intel, Checkpoint, Palo, all of those vendors out there, all the ones that you're using in either the in-guest or in the physical perimeter security model. So from a micro-segmentation perspective, again, micro-segmentation being the ability to segment my network down to the individual workload, the individual app, in this case, the individual virtual desktop. I've got a firewall that exists because it's part of NSX at the individual virtual NIC of every one of my VMs. That means if I want to keep this virtual desktop from talking to any other virtual desktop on the network, I can do that. And it never touches the network, the physical network. It's all inside of the hypervisor. But what I can also do is I can take a single pool of desktops and I can logically break it up into vertical slices based on the user who's logged in. In other words, when I log into a workstation and you log into a workstation, we have different needs for the same workstation. We may have different application sets, that can be deployed via app volumes or profile unity or whatever you're using to deliver your applications. We can get different sets of apps that are delivered to us, and that's fine. We've had that capability. That's nothing shocking. Now, I can have access to certain web apps, and you can have access to certain web apps, and I may not be authorized to get to yours. And I can segment all of that traffic at the virtual NIC level because vSphere knows that I'm logged in and not you. And it only allows me to gain access to what I want. So another way to look at it is I can create these policies that allow user, we call it identity firewall. It's user identity-based firewall rules. So it's not static in the sense that I'm putting a firewall rule on a virtual machine. I'm putting a firewall rule on a user, and it can apply to every one of my users or groups that log into the same machine. So as I log off and you log in, the policy changes dynamically. And there's nothing required on the physical world to be able to make that change to accommodate that. Does that make sense? So I'll let you read through this. Basically everything I just said, right? We're now able to take the combination of app delivery and access, dynamic access controls, and make those available. If you were trying to get to stateless VDI, which I've been telling customers they should be going to for 6 years, even though you couldn't really, you now really truly can. One desktop pool across a bunch of networks, because the network really doesn't matter anymore. The network is all inside of NSX. And I'm going to control which apps you get when you log in, and I'm going to control what sites you can talk to, where you can go on the network when you log in. The stateless desktop has really, really become real and still not giving up any security whatsoever. So today, a VM wants to talk. A hypervisor takes the packet, it puts it on the network, it travels through your physical fabric, and if you're sending it out to your firewall for inspection, the firewall can stop it. Right? But it's already traveled throughout your network at that point. That may or may not be a problem for you. In this model, where NSX is introduced, the security policy is now part of the virtual machine, so it gets deployed with the VM. When the VM now sends a packet, it's filtered right here on the box. It never touches the physical wire. Because the firewall rules exist, they're programmed centrally, but they exist on every single ESX host in my environment. Good? If that VM moves, the policy moves with it. This can be moving across to another rack, can be moving to another data center, can be moving to a cloud-hosted data center on the other side of the country. It really doesn't matter. The firewall policy is now part of the VM. Right? Doesn't matter where that VM goes. That VM can be here one day, it can be in California the next day. Still got the same IP address, the same MAC address, the same firewall rules. They exist in both places. They exist everywhere that you have a data center where you want this workload to run. And everything continues to work. But, any firewall administrators in the room? Anybody stuck managing a firewall? Here's the best part for you guys. When the VM gets deleted, so does the rule. There's no more rules hanging around. The rule's part of the VM. I don't need a rule anymore once I delete that VM. It doesn't matter much in a virtual desktop world. But think about how many apps were deployed, lived their life, and went away, and you never deleted the rule in the firewall because you're not sure if anything else was using it. But other apps deployed over time that may have been taking advantage of that port. Nobody wants to be the guy who removes that rule. So they just stay there, right? We're getting rid of that now because the network policy is now part of it. Now, I'm not saying your firewall goes away. Your firewall stays. And it's still got all the rules it has today. But it's only managed in north-south. And when you want to clean it up, you can. Because you can go look at the history of the rules that are firing, and all those ones that haven't fired in 6 months, they're not firing because they were east-west rules. And they're all being handled now inside of NSX, and you can go clean them up. If you're doing it today, this is what it looks like. If I got a blade with 2 VMs running on it, and they want to talk to each other, this is layer 2 traffic. I'm sorry, layer 3 traffic. They've got to go all the way up to the FI, to the router, to the firewall, and all the way back in, even if they're running on the same box, right? Just because that's the way we segment it. If I do my layer 2, my layer 3, and my layer 4 firewall all inside of the box, guess what? They never leave the host. This is 2 VMs on 2 separate subnets. I'm getting all of the same functionality, but I'm staying on box at line speed, right? If they are actually running on 2 different switches, same thing, I still got to go all the way up and out, so same number of hops. I actually, in the case of blades, I do actually have to get to the FI. I have to get connectivity between the two hosts. But I'm still saving a dramatic amount of traffic that's traversing my network once I start to optimize my east-west traffic. Does that make sense? Okay. So here's what I get to, right? Today I typically silo, or I typically build my VLANs either by the types of machines or by the individual apps. Let's say we're breaking them up by types of machines. Obviously, I got a DMZ where I drop all my web servers. I've got app servers and database servers. And I control what's in between them by sending it out to a firewall so that the firewall can inspect that it's legitimate traffic going from web to app and app to DB. I really don't get any control this way. Once I use NSX, I can now build these silos that are logical. I can still control the traffic that flows in between these from a web to app to DB, but I can also logically silo it based on the individual app or the types of users allowed to access those apps. So because this is all based on logical constructs, I can organize my data center anywhere I want now, and my security policies any way I want. Do you have a question? Good. Just a quick screenshot, just to make one key point. They're 5-tuple rules, but they're no longer IP or MAC address based. They can be, they don't have to be. In a VDI environment, how many desktops? Approximately. Thousands, tens of thousands? 10,000. So if you wanted to segment your individual desktops, it'd be difficult. You could segment all the VLANs, right? Let's say you're using Class Cs. I could segment all those. If one of them gets compromised, I'm going to hope that my IPS is going to take care of it, because otherwise that attacker's got 254 desktops, right? 253, right? Because they all have the same operating system. They're all in the same subnet, and there's nothing looking at that traffic. In this model, I create a rule that says VDI desktops. Anything in the VDI desktop security group, trying to talk to anything else in the VDI desktop security group across any protocol, I'm going to block it. I've just severed communication between every single desktop in my environment. One firewall rule. These are logical constructs. That security group membership could be based on what network they're logged into. It could be based on what operating system they're running. I can create a security group and say, I want everything running Windows 7 to be in this group. Or I want everything in this IP range to be in this group. Or everything in this MAC address range to be in this group. Or everything with VDI in the host name to be in the security group. I can do anything I want because it's all logical and it's all in software. I don't care what the IP address is. And when this thing moves across the country, it can keep the same IP address, but even if it didn't, it doesn't matter because it's still part of that security group if I chose criteria like host name to be able to determine membership. And then, of course, I'm not going to go through all these. I just kind of wanted to make a point that logical constructs now dramatically change how we create firewall rules. So I get all these native security capabilities that are now built into the hypervisor, right? We get incredible throughput. When I need to scale out my firewall rule, I don't need to go back and buy more. I add another host. I get another 20 gig of throughput, right? I got 2 10 gig NICs. I get 20 gig more throughput because there's a firewall in every single host, on every single virtual NIC, on every single host that's running inside of my environment. So it's very easy for me to automate and manage this environment now once we bring all those capabilities into software. But I don't do everything. I don't do antivirus. I don't do IPS. I don't do next-gen firewalling. That's not my core competency. That's the core competency of all the partners. So let's go back to this model, right? We already understand the benefits there. If I've got all this capability baked in, and I were to expose that via some API to my third party, to my partners, to the security vendors out there, they can now, whether they're down here, let's take your checkpoint firewalls, Palo Altos, who's got a Palo? Anybody? Take your Palo Alto firewall rule, right? Right now, we talked about it, right? They've got great isolation. They don't have much context. They can look inside the packet at layer 7 and they might be able to see who's doing what, but they may not. But now I can give Palo Alto full context of what's going on inside the environment because Palo exists here now, not just here. Symantec currently exists here. What if I want to give them the true isolation that comes if they were to be a physical appliance? The ability to disconnect a port right here on a virtual machine, right? I can now do that. And that's the reason that every single security partner out there is coming to partner with us. Because their products get better once they integrate with NSX. Whether they're at the top or bottom of that spectrum, they get more capabilities now as they start to integrate. And it's not just security, right? I mean, F5 can build virtual load balancers now that are dynamically provisioned on demand by a cloud platform without even administrator intervention. Just because I deployed another web server, I can automatically reconfigure the F5 load balancer because of the integration with this NetX API that we expose as part of NSX. Make sense? So you guys are already familiar with this, right? I don't have to put an antivirus engine inside of every single VM, right? It's a resource hog, right? If I can have one on every single host and allow that same API to be able to look inside the memory and the disk of what's going on inside my virtual machine so it can still do its job, but cut back on resources. Oh, and by the way, not be able to be compromised by the worm that it's trying to detect. We got this today, right? This is part of vShield. vShield is coming up on end of life. NSX is going to take over this capability, but it's adding more beyond just anti-malware. It's adding things like integration for DLP. It's adding things like IDS and IPS. So this story is getting even better. Now let's talk about next-gen firewalls, and I'm using Palo Alto just as an example. They were the first ones to jump on board. When you deploy Panorama, it integrates directly with NSX Manager. NSX Manager now controls the dissemination of the virtual Palo Altos across your environment. So that's cool. When I add a new host, it automatically gets the Palo Alto. I don't have to worry about anything. But here's what's cooler. When the administrator for the Panorama goes and creates a security policy, he creates it one time. That policy automatically applies to his physical boxes as well as every single virtual edition of a Palo Alto across the entire environment. So now, when that VM tries to talk, let's just assume that it's legitimate port 80 traffic and it gets through my layer 4 firewall. What happens is before it's introduced to the network, the redirection rule is going to steer that traffic to the on-host security appliance. Your Palo Alto rules are now doing next-gen deep packet inspection on box before it ever touches the network. And this is what I was talking about the benefits that even our security partners get now from integration with NSX. This one's the part I really like from a VDI environment because I know you guys all love to get paged in the middle of the night when things go wrong. But let's face it, things go wrong in the middle of the night. So I've got a VDI environment. I've got a standard desktop policy that says, yeah, I'm not going to let anybody talk. Okay, I'm going to prevent any, because unless you're allowing peer-to-peer, there's no reason two machines should ever talk, right? Just shouldn't be allowed, except maybe for administrators who want to do maintenance on an end user. I'm permitting HTTP, HTTPS, and I've got it set up for a virus scan. And it doesn't really matter who your antivirus is, as long as they integrate with NSX and they take advantage of our security tags. So now, and I also create this quarantine zone, and this is kind of out of the box, right? What you do is you set up the policy of how you want to respond when something is determined to be quarantined, right? So now I run my third-party antivirus tool, Symantec, Trend, whatever it is, and they identify these two machines as being a problem. They apply a tag to that virtual machine that says virus found. Those security groups that I was talking about earlier automatically are updated. This machine now, because it has this tag, immediately moves from the standard desktop policy to the quarantine policy. That quarantine policy now not only blocks VDI to VDI, it blocks everything except for your remediation tool. This VM was just removed from service And the only thing that's allowed to talk to it right now is your antivirus engine to try and clean it. And it was dynamic. You may have gotten a page because you like to know, but it happened no matter what, without you touching a thing. When your remediation server goes through and removes that worm, that tag's removed, it's automatically, based on the previous criteria, dropped back into the standard desktop policy. It's reconnected to the network and everything continues running. It could have been deleted via something with vRealize Operations or some other integration that you guys built so that as soon as it gets a virus, it gets deleted. It may have. Some people actually choose to use this quarantine capability not to isolate it, but to move it from the production network to a honeypot network so they can figure out, what is he trying to do? Is it really with government customers, we were about state-sponsored attacks and things like that, right? But what was the attack? Was it just a virus because my user's an idiot? Or was it something more? Was somebody really trying to compromise my environment for some hostile purpose? So they move it to a honeypot and they make it look like a real network and they just watch. What is this guy doing? Is it something I need to worry about? Do I need to call the FBI? What do I need to do, right? So to me, this is probably the coolest thing as it relates to VDI, is the ability to self-heal your least secure users inside of your environment. So that's really the security aspects as they relate to VDI in a nutshell. What NSX does is faithfully reproduce all of your current network services inside of software inside of NSX. It makes those available to every workload that's virtual inside of your environment. There's a whole lot more to the story about how we work with physical workloads and how we manage and firewall all of that traffic, and not really relevant to what we're talking about today, certainly not in 45 minutes. Questions? Does that make sense? That stateless desktop now can truly be a single pool of stateless desktops. Your admin users log in, they get their admin tools, and they get access to do whatever they want on the network. Your regular users log in, they get the tools that are relevant to the security group they belong to, and they only get access to touch the servers that matter to you or matter to them inside of the environment. And it works whether it's Citrix, it works whether it's Horizon, doesn't matter. Questions? You guys, all a bunch of EUC guys came here and they have no idea why you're listening to a security pitch. That's all I have. Thank you very much. I'm certainly going to be hanging around for a little while, although I hear I need to get to the airport like 3 hours in advance based on some fun that goes on at MSP now. But I'm certainly here to answer any questions or anything else I can do. Thanks, guys.